You spoiled that. No, I predicted it.
What's the difference between December 6th and reciprocal ratios? One's a date on the calendar and one's a math theory. I don't remember. I'm glad.
All right, folks, let's get started. So today we are looking at something called reciprocal ratios. Some new words: cosecant, secant, cotangent. I feel like secant, is that like a French word? Secant? I don't know. Doesn't it sound French? I don't know. All right. Learning goals for today. So today is to understand the relationship between primary trig ratios and reciprocal ratios. Also, to learn to use my calculator, okay, to determine the value of reciprocal ratios. And today, one of the goals is we're going to practice converting or changing our calculator into radians. Even though you're not going to be tested on it, it is a bit challenging. So I want you to have some practice changing your calculator into radians so that next year you are pros. All right. So let's remind ourselves that when we are comparing sides of triangles, we have these ratios that help us compare the sides. We have a sine ratio, a cosine ratio, and a tangent ratio. Now, what did we learn or what did we decide about the sine ratio and the cosine ratio in terms of whether or not they are greater than 1, less than 1, or it doesn't matter? Tell me what you know about sine. What is it always? What is the ratio always? Pardon? No, it could be negative because of cast rule, right? If I put a 1 here, what do I put between here? Is it always greater than 1, always less than 1, or could be any of them? Okay. Let's think about what is sine. So sine is the ratio when we are comparing the lengths of the opposite side over the hypotenuse. We're comparing them. What do you know about these two sides? And how is that going to inform what you put right here? Okay, so what is the answer, folks? Always less than. That's right. Because what? Hypotenuse is always the longest side. How about cosine? Can we say the same thing? Yeah. So cosine is always less than 1 because hypotenuse is always the longest side. How about tangent? It could be anything. It could be less than 1. It can be greater than 1. And here's a question. Can these ratios all be positive or negative? Yep. Based on what? The cast rule. The cast rule tells us that these ratios can either be positive or negative, right? So when we're doing trigonometry with a triangle, we'll use these formulas, right? If I have a triangle, I'll say opposite, adjacent, hypotenuse. However, as we've learned in lesson 2 maybe, when I'm working with rotational trigonometry, when I have a terminal arm and I have a point on that terminal arm, I use these equations or these formulas, right? So I take that point on the terminal arm. That's my x and y. I can calculate r. How do I find r? Oh, yeah, I use the right angle theorem. And I can use these formulas. So we sort of have two different ways of finding the ratio. In the end, these formulas are still opposite and adjacent and all that because we're looking at the related acute angle. But we've got two ways. So now let's remind ourselves, as I move to the reciprocal ratios, let's first remind ourselves, what is a reciprocal? If I have 3 over 5, what is the reciprocal of 3 over 5? Folks, okay, that's the reciprocal of 1 over 3. Oh, sorry, of 3 over 5, right? So the numerator becomes the denominator and vice versa. That's the reciprocal, okay? Do you know which concept someone might confuse this with? What is it? Someone said it. The inverse. The inverse and the reciprocal can be confusing because sometimes they are identical, right? Like if I've got, for example, if I have 3, well, the reciprocal of 3 is 1 over 3. However, if that 3 is multiplying something, well, the inverse of multiplying is dividing. And so in this case, if I have x times 3 and x times 1 over 3, it could be both the inverse and the reciprocal, okay? That's why inverse and reciprocal can be mixed up. But in trigonometry, that's not true. Right now, I'm going to teach you about reciprocal ratios, but we've actually talked about inverse ratios, okay? So sorry, I'm making notes all over the place. What is the inverse of sine theta? Now, inverse. Remember, inverse is undo. It's the undo function. When we had the inverse function machine, it was just Control Z, Control Z, Control Z. We were undoing. Okay. So if I'm trying to undo or do the opposite operation of sine theta, what is the inverse of that? Sine inverse, right? Is the sine inverse, right? So in trigonometry, the reciprocal and the inverse are not the same thing. This is the inverse. Today, I'm teaching you an entire lesson on reciprocals. Got it? So what are reciprocals? Well, for our purposes, reciprocals are when the numerator and denominator flip, because we're undoing itself. So if I look at these formulas and sine is opposite over hypotenuse, what is going to be the reciprocal of opposite over hypotenuse? That's right. Right, I'll just use the short form, hyp over op. Now, the reciprocal of sine, the reciprocal ratio of sine has a name. It's called cosecant. Cosecant. And the short form of cosecant is CSC. And don't forget to add the theta sign, because we're saying the cosecant of an angle is this ratio. So that when we're taking cosecant, we're comparing how much longer is the hypotenuse from the opposite side, right? That's what that information tells us. Okay. The next ratio we've been working with is cosine. And cosine is adjacent over hypotenuse. So what's the reciprocal of that? Great. And this reciprocal ratio is called secant. And the short form of secant is SEC. Notice that cosecant goes with sine and cosine goes with secant. So each of those has only one co. Sine and cosecant, cosine and secant. So each one of those pairs has only one co. Do you see what I mean there? And I say this because I find that I often would get mixed up with cosecant and secant, which one gets which one, right? And it's like, oh, if you remember that with these pairings, each pairing has only one co, then you know to assign cosecant with sine. The last ratio is tangent, and that is opposite over adjacent. So the reciprocal of that is going to be adjacent over opposite. And the name of the reciprocal ratio is called cotangent. Again, that pairing has one co. And the short form of cotangent is COT. Before I move on, I want to return to the idea that we said that sine and cosine are always less than 1 because the hypotenuse is always bigger than the side on top. So what does that mean for cosecant and secant? Don't tell me. Tell your elbow partner. Right? Is that what we all said? I heard everyone saying it. Yeah, they're always going to be greater than what? Did I hear that there's a question? Do you have a question?
No, I was just gonna ask if these formulas would be on the sine y over r.
Okay. So which formulas do you get? You get,
Yeah, that's what I was gonna ask. Like sine y over r.
I think you get primary trig ratios. You get this y over r.
Okay.
And I think I even give you that sine and cosecant, their relationship.
Okay.
Yeah. I'll tell you for sure on Monday, but I give you quite a lot. Okay. All right. And then how about cotangent? Is cotangent always greater than 1, always less than 1, or neither? Right? It could be. It just depends which one's longer. If the adjacent side is longer, what will you get for cotangent? Greater than 1. If opposite is longer, what do you get? Beautiful. Right? So I really want to drive home the idea that that number that you get, let's say we get 1.56, it's not a random number. It actually means something. If I were to get that cotangent is 1.56, what that means is that the adjacent side is 1.56 times longer than the opposite side. That's what it actually means, right? I'm going to say that again. So if my cotangent ratio ends up being 1.56, it tells me that the adjacent side is 1.56 times longer than the opposite side. Kind of got it? That's what that number is telling us. Okay. Yes.
Can you determine the lengths of sides with just that?
No. Yeah, so that's a question. So the question is, and that's a good question. Let's say, I'm just going to give a really simple number. Let's say I'm told that cotangent is equal to 2. So what does that mean? What does the 2 mean? Tell your elbow partner. Okay, so here's a follow-up question that I really liked. So knowing this ratio, can you determine the length of the sides? Yes, no, justify your answer, go and talk to your partner. But you don't know that. If you know it, then you can. Yes. All right, let's come back. So if you have no information about adjacent and opposite, you just know that adjacent is twice as long, can you determine the lengths? But if you know that the opposite side is equal to 5 centimeters, what is the adjacent side going to be equal to? That's right. That's primary trig ratios, folks. That's what we've been doing, right? That's what SOHCAHTOA is actually all about. Okay, now again, I'm taking this 2 off just to not confuse people who are copying the note. All right, let's take it over to the other side of rotational trig. So the only difference when we're talking about rotational trig is we don't have a triangle, we have a terminal arm. That terminal arm has a point, it's X and Y, and we can find the radius, right? We can find the arm. So that's sort of the difference. So let's see how we would figure out cosecant, secant, and cotangent. So if I look above, I see that cosecant, now I remember that cosecant is the reciprocal of sine, and if sine is y over r, what do we write for cosecant? Gorgeous. Secant is the reciprocal of cosine. So what's the formula for secant? Right? Again, r is the hypotenuse. That's why r is on top. And cotangent, what do we get? Beautiful. So all you did is you looked at the existing formulas and you flipped them, right? You took the reciprocal of them. Okay, let's make a little summary here. So what we're saying is that sine theta is the same as 1 over cosecant theta. Cosine theta is the same as the reciprocal of secant theta. And tan theta is the reciprocal of cotangent theta. Likewise, let's write the opposite. Now let's write, I need a new color. How would I express cosecant in terms of sine? Well, I would say it's the reciprocal of sine. If I want to express secant in terms of cosine, it's the reciprocal of cosine theta. And cotangent is the reciprocal of tan theta. Got it? That's our little summary table. So we can see which ones are related. And it's a reciprocal where it's like we're flipping the fraction, right? Like, watch this. If I was like, how did you get 1 over sine? Well, it's like I'm going cosecant over 1 kind of thing. Right? It's just, we're just changing the numerator denominator situation thing. All right. Is that a question? Yes. Okay. Now, can you take your calculators out? If you do not have one, come up and borrow one. And find the cosecant, secant, and cotangent button, please. Okay, I just need to get a tiny bit more milk. Let me just, can I pause this? Keep looking. I just need to quickly get some.
Wait, you can do Wait, you can do functions with this. Actually, I understand very well. Find how much is there. I get it, but like maybe this is what you can use. Yeah, I do.
They really got me. I thought
You can't. I don't know. No, to me, this is whatever you do.
This is the ratio of this and so maybe the fact that C is so easy because I have no idea what we're doing. So you think I can do this? Easy. Like I already know the step, but it's like complicated.
Now we're on G.
Avocado.
I make a few cards. No, I make a few
Okay, who found the button?
I did.
No one has the. Which calculators do you have? Folks, you found the one on the school calculator, right? I hope you don't have to buy another calculator. Oh, I would hate to send you guys to buy more calculators, but you might have to do that. Fooled ya. Fooled ya. I mean, if you read the next line. I know. All right. The three new ratios are simply, they're not new ratios, right? They're reciprocals of the old ones. So we don't need buttons for that. Okay? Your calculator will likely not have those buttons. So we do have to figure out a way to use the primary trig ratios and find the reciprocals. Okay. So let's practice that. Example 1, evaluate the following. Note, if an angle has no degree sign, it means it's in radians. So which example, A or B, is in radians? Good. All right, so far we don't have to change it. We're going to start with secant of 43.6. Now, I don't have the button. None of us do. So what do we know about secant? This is what we know. Watch here. Secant is 1 over cos of the same angle. So what can I do? Well, this is what I can do. Now, in this case, I want you to use the proper button. I do not want you to type 1 divided by. So which button are you looking for? No, I don't want you using fraction. I want you to recognize that this is a reciprocal button, right? So x to the power of -1 Or your calculator might have 1 over x. Or if it doesn't, you might have to use the x to the y button and input an exponent of -1. Please don't do fraction. Please use if you're using this button, you're showing that you understand that it's a reciprocal. And what we are looking for is approximately, I'm going to give you the answer so that you can see if you're on the right track, 1.38.
That's what I got from
Yeah, but if I
doing.
do the fraction, I still get
I know, but I want you to, it's more sophisticated mathematically. Lydia, it's more sophisticated to use these buttons. Okay? Really? It's literally on top of the 7. I know.
Something you're outside, right?
So emphasized. Anyone else? Calculator issues. Oh, so this is what you do. You've got the XY.
Silly song. You just all I have to do.
So you're gonna write
information.
cosecant 43 cosine 43.6, y to the x -1.
I got the wrong answer.
Okay, so I want to show a possible, folks, I want to show a possible calculator error. So I had a student do this. Right? The student put that in, press -1, which essentially is this. Some calculators will take it. Some calculators will not. What do you think was missing? Yes. And so what the calculator took this as is 1 over 43.6. Do you see that? So you want to add brackets around the entire cosine if you need to. Okay? So again, every calculator is different, and that's why you really want to use the same one all the time. So that's just a possible error. All right. So please make sure, if anyone, no, bring it up here. Okay. So you went, you're in degrees, great. You did cos 43.6. And then you used this. Okay, and in cos 43.6, close brackets.
Oh, I'm supposed to do over cos as well.
Yeah.
Oh, that's fine.
Yeah. Any other questions? We all got it? Excellent. All right. Moving on to question B. So first of all, I can't find the cosecant using my calculator, so I need to use the reciprocal. What is the reciprocal of cosecant? Gorgeous. 1 over sine 3.42. Now, we must put our calculator into radian mode. So some people have the please stop talking, listen to this. Some people have the DRG button. Not this one. If you have a DRG with an arrow, that means it's just going to convert your answer. But you don't want that one. You want to fully go into mode. So you might need to go into setup to find radians, or you might need to press mode twice to find an opportunity to change your calculator into radians. And you found it. Oh, do you have setup on your calculator?
Radians, I found it.
Good. Anyone not able to find how to convert into radians? And let me give you the answer so that It's negative 3.64. Okay, so let's make sure that we're.
I didn't realize that.
Yeah. Here, let me, folks, I'm going to break this up. Sine,
Oh, I got it.
I also need my reference. So happy. Should I use that as a reference? Yeah.
Oh!
Use me.
Okay, this is the middle step. If anyone having trouble. Okay, so first of all, make sure that sine 3.42 is negative 0.2748. Right? That this, if you get this, your radians are working, and then it's a reciprocal problem. Did you get this part? Or switching into radians mode. I don't want converting. No, I don't want you using that. So you have to go to settings. Radians. Oh! Oh, sorry. I thought you were watching it. Oh, that's reversible. You're in radians. You see it?
So like during the test,
Oh.
switch back and forth.
Well, grade 12, yes.
Yeah.
I think it's gonna be.
Because they showed you green.
Oh no, Jesus.
No, and then you have to select radians. Anyone else
So much
having?
power. We're just like
Yes.
Be like, oh my god.
no, I'm kidding.
Me obey me.
No, I think
I'm
gonna trade him again.
no way. Once you get out, wait. If you get out, you can still make trade. I don't know.
Why would I trade him?
Mostly go after the makes sense. Because then in playoffs, you get magically better. Tell them a day before so they can't like decide if they want to trade.
I mean, that's it, but that's kind of complicated. That's so weird. Just to show, like, sine of 3.42 is that negative. Did you get 3.48 or 3.64? Like, even I yeah. I don't want you using this one because I'm not going to let you use it on a test. So can you use this one during class? Like throw this out. Say, Dad. Tell Dad. Say, Dad, stop giving me free old calculators from school. Buy me a real calculator. Okay? Yes, you cannot use that. Like, I will take it away on a test because you can graph a function there. I don't care. You can do it. You can get a table of values. Okay? You can put in values and get the equation. Okay? So, use this one. Yeah. Tell Papa you're getting me in trouble. DRG. Press that to switch. All right, are we good? We figured it out? Give yourself a pat on the back and be like, oh my gosh, I just did some grade 12 work. Ooh, I'm so fancy. Go ask your friends. Do you know how to use radians? Yeah. I bet you some of them are going to be like, what? Right? Well, no, I would never say that. All right. Okay. Yes. Moving on. Back to degrees. Go right back to degrees. That little. Okay. Read the next question and tell me what word pops out as a really important hint. One word. Exactly. Yeah.
How come we use radian, whatever radiaform for cosecant but not secant?
Because it says degrees. See that degree sign?
Oh, so it says degrees. We don't.
Yes.
do degree? Oh, that's.
Yes. See this note? If an angle has no degree sign, it is in radians.
But there won't be ratings on the test.
Correct. Yeah. You don't have to worry about it on the test.
So it's gonna be in degrees.
Yeah. Every angle given to you on the test is in degrees. Promise. All right. Example 2. Evaluate the following. Find the exact ratio. Oh, what does exact tell you?
No calculator.
No calc. It says instead, what can we use? Special triangles, right? Oh, yeah. Okay. So let's start with the first one. Cotangent of 240. I can't use a calculator, so I can't just punch it in. So I need to understand where 240 is. So I draw my little diagram.
Quite simple.
I find my terminal arm. I draw my angle. So from this diagram right now, I can get 2 really important pieces of information. What is one of those pieces? Or, yeah. Right. So you're suggesting that I use the cast rule to find some important information. But the cast rule is CAST. That's sine, cosine, tangent. However, let's say my cosine of a theta is like, I don't know, 1/2, positive. Well, secant is going to be 2/1. What can you say about the sine of both of these? Positive. If cosine is negative, if it's negative 1/2, well, then I'd get 2/-1. So the reciprocal ratios always have the same sign. So cast rule applies. Okay, so I have to do a few extra steps of thinking. So this question is asking me about cotangent. What is the reciprocal primary ratio of cotangent? Tangent. And so if I am in the third quadrant, what will tangent be? Tangent will be positive. As a result, cotangent will be positive as well. Does that make sense? All right. So I know it's going to be positive. Now I need to find the ratio piece, and I do that using the special triangles. So what do I need to know? 1 second. Yeah. The RAA. Hi, come on in.
Hi there, we have an announcement.
Thank you.
Hi everyone, we are here on behalf of YFF, the school's Young Feminist Forum, to speak to you about a dark moment in our history, the Montreal Massacre of December 6, 1989, of which today is the anniversary. On that day, at L'École Polytechnique in Montreal, 14 women were tragically murdered by a lone gunman with misogynistic motives. This horrific event spurred a national movement against gender-based violence, leading to the declaration of December 6th
as the National Day of Remembrance and Action on Violence Against Women in Canada. It's a day to reflect on the systemic issues that perpetuate gender-based violence and renew a commitment to creating a society free from fear.
Today we are collecting donations for the Red Door Shelter, a shelter providing emergency shelter and support for women and children affected by domestic abuse, families experiencing a housing crisis, and refugee claimants with nowhere else to turn. In exchange for a donation, you will receive a white ribbon. This white ribbon represents the movement to end gender-based violence and promote equality for all genders.
So if anybody has any donations, you can take them now. And then also, if you don't have any today, you can bring them to the foyer on Monday at lunch. Does anybody have any donations?
Anyone want to make a donation?
Any change at all would be appreciated.
I would like to change.
Okay, I'll go look. I'll just quickly go get my.
Can you wash your teeth?
Which way do you talk? See what I got.
I don't have money. Bro, this is for my fantasy.
Does anyone else have any?
Yo, Ethan. Ethan Morris. Ethan Morris. Ethan Morris. Ethan
Yeah, here's my card. Yeah. Tap away. Thank you.
Oh yeah.
I was tattooed between the whole time.
Say where's the bro you were?
I can show you.
Yo, show me.
Wait, how?
Yo, let me write it
Bro,
down.
it's so easy. Yes, let me take a picture.
No, let me take a picture.
Oh, wait.
And I'll grab
These
that
are
too.
not to do, like, good
Yes,
pieces.
they will.
No, I was just asking.
Thank you so much.
Thank you, guys.
Have a great day.
I already have to
Well, I'm going in that lunch to do it.
Yeah, should I? Oh, you're not doing it? You're not doing it?
I was there yesterday.
Oh, yeah.
Too busy getting on.
All right.
First woman?
Okay, let's return to the lesson. So we've just discussed the fact that the caste rule applies, that reciprocal ratios have the same signs. Okay? And so that means that in the third quadrant, cotangent will be positive. So we've got the sign. Now we need the ratio, like the fraction. And so to do that, we turn to the RAA, the related acute angle. So how far is 240 from 180? 60 degrees. Okay, so that means I need my 60-30 triangle. And folks, I would encourage you to draw this by heart as much as you can. You will have the triangles on the test, but again, the more it's committed to your memory, you don't have to flip the page, right?
So we'll have these on the test.
Yeah, the two triangles, yeah.
With all the guys labeled.
Mm-hmm. You will. Okay. So having this, now I'm finding the cotangent. So remember, the cotangent is the reciprocal of tangent. So if tangent of 60 is opposite over adjacent, what is cotangent of 60? Adjacent over opposite. And tell me, I know the textbook is satisfied with this answer, but why are we not satisfied? What must we do? Give me the gorgeous. Rationalize the denominator. We multiply everything by root 3, and we end up with root 3 over 3. That's the final answer, positive root 3 over 3. That is an exact answer. All right, moving on to the next one. Okay, what is this? Is this angle in radians or degrees? Okay, so first thing, let's move to the side and convert it. What's pi over 6? 30 degrees. Gorgeous. So 9 times 30 degrees. Oh, I'm looking for cosecant of 270 degrees. 270 degrees. Interesting. Let me draw it. I want to see which quadrant I'm in. That's funny, Miss Sly. You're not in any quadrant at all. Oh, 90, 180, 270. Oh, I'm in the negative y-axis. Ooh. Which tool do I use now? The unit circle, right? Tool alert, get the unit circle out. Now, I'm not going to actually turn to the unit circle. I'm going to show you what I do to figure it out, okay? Because it's better to memorize how to do it as opposed to just having to memorize the entire circle. So what we did is we took a point on the terminal arm. And what was the point here? 0, -1. Wait, right? And in the unit circle, what is the r always equal to? 1. Right? So x is 0, y is -1, r equals 1. So I don't even have to look at my unit circle. I just remember, okay, take a point on the terminal arm that has a length of 1. Okay. So cosecant is the reciprocal of which one? Sine. And sine is y over r. As such, what is cosecant? R over y. And in this case, it's 1 over -1. And the answer is -1. That's what cosecant of 270 is. Yes?
Will you give us like sine theta equal to y over r and stuff?
Yes, I will. I will. The question was, will I give you the formulas that sine theta is y over r, cos is x over r? Yes, I will. We good here? So in this case, so what I want to come back to, folks, is my notes here. When I read exact ratio, I was like, okay, no calculator. I have to use special triangles. But there's another tool. I use special triangles or I use the unit circle. Now that we know the unit circle, then I can find the ratios using that. Yeah. Yeah. All right. So far, we've been finding the ratio. Okay, in example 1 and example 2, I'm finding the ratio. What do I do when I have to find the angle? Okay, well, let's look at example 2 again. All right, so in this one, we are finding the angle. So we need to follow a different set of steps. Did I show you my mind map there, my tool sheet? Or is that the other class? All right, so let me just show you this tool sheet. So in trig, most of the time you're being asked to find one of two possibilities. You're either finding the angle or you're finding the ratio, right? So they're saying what is the ratio or what is the angle? If you're finding the angle, you use cast and special triangles or unit circle. Okay, what did the cast rule tell us? Well, the cast rule tells us which quadrant the angle would be in. The special triangle would tell us the RAA, or the unit circle would. Okay, this is, and here you are given a ratio. If you are given an angle and you are asked to find the ratio, we use the same tools. What would cast rule tell us? It's not telling us which quadrants it's in, right? That doesn't matter necessarily. What does the cast rule tell us about the ratio? Yeah. Beautiful. Positive or negative. Absolutely. And then we've got the special triangles or unit circle. What do they give us? Yeah. So special triangles, when I'm looking for the angle, give me the RAA, and then I can do some calculations to find the angles. I'm not looking for an angle here. I'm looking for a ratio. Yes. Yeah, like the fraction, the x, y, the r, the fraction. Right? So the cast rule tells us if it's going to be positive or negative, and the special triangles or the unit circle gives me like what the actual values will be. Okay, so this is sort of, I really encourage you to do this kind of thinking because, guys, this is helpful. And I know for you, this is going to be helpful. But do you know what's even more helpful? Is coming up with this mind map. Right? If you were like, what are the relationships? What are the steps? How do I use these tools? If you struggled with it and you yourself come up with this map, that is so much more valuable. Okay? So I'm modeling it for you so that you can start making these types of mind maps. Okay. So we're finding an angle, meaning we're going to the left side of my mind map, right? We are told that cotangent of theta is 1.921. We are also told that the angle is between 0 and 360 degrees. So here's a quick question. Everyone, CTB. How many angles will I have? This can be really quick. How many? No. Yeah. Why do I have 2? Cotangent is positive in 2 quadrants. And we're going once around, right? Quick like that. 2, 4, 6. Okay. So again, I don't have a button to find the cotangent inverse. Okay. But what I do know is I know that tangent of theta, how do I write that? Yes. So if I write 1.921 as a fraction, then I'm like, oh, so tangent of theta is 1 over, right? I write the reciprocal. Now, can I do this on my calculator? Which button will I be using on my calculator? The inverse of tan. This is a question that really highlights the differences between the inverse and the reciprocal. I love asking some type of communication question on the test where I'm asking you to compare the reciprocal of a trig ratio and an inverse of a trig ratio because they're not the same thing and they have a different function. Okay, punch it into your calculator. Let's give our answer to the nearest degree. Did people get 27?
Yeah.
All right. So, yeah.
I mean, if you use the inverse button for this, or like if you want us to do like, we also can do it as like.
Oh, I'm not checking how you're doing your calculator.
But like we can do it either way.
You can. Yeah, I'm encouraging you to use your calculator in a more sophisticated way, right? But yeah, I'm not checking. Anyone not get 27? We're on track. Did you get it now? The people that didn't before? Now here's the question. Is this my answer? No. What is this that I found actually? The RAA. It might be one of my answers, but what I have found here is my RAA. Okay. So now let's draw my diagram to figure this out. Okay, so cotangent is positive in quadrant 1 and quadrant 3. And the truth is, I drew it as 2 lines. It is 1 line. So the first angle is 27. And the second angle is going to be 27 more than 180. So that's 207 degrees. And so we'll make a statement to say, therefore, theta equals 27 degrees, comma, 207 degrees. You don't say or, it's an and. There are 2 possible answers. How do I know that I don't have to keep going and giving bigger and bigger numbers? Yeah.
Because it says it's equal to or less than 360.
Great. The restriction tells us to stop at 360. Excellent. In the next question, we have a wider range of angles. It's snowing. Do you know what's really fun to do on Friday night? Go sledding! Please don't go to Lithuania Park. But High Park has some excellent hills. The hill off of Parkside is great. The hill in the dog park is really good if it's icy. Yeah. Pardon? Because it has that post. And I've heard of so many people getting concussions. I've never gone there actually. But I don't recommend doing this because it's unsafe, I think. But I go through forests. Yeah, when I used to take my dog when I had a dog, I would take him to the dog park and my son and I would sit on the sled and we would weave through the trees. It was amazing. It's dangerous, but I'm really good at steering. Actually, because then and you have to use your feet to steer, but it's so fun. It's so much better than just going to Swansea. No, concussions are no fun at all. All right. Enough sledding talk. I could go on forever. Good. All right. Christy Pitts is a good one. Pardon? No. Put a helmet on. All right, guys, let's get to work. Example 3, which is actually example 4. Determine the measure of theta, where secant theta is 2.5, and this is the range we're working in. So, on the mind map, what am I looking to find? Angle or ratio? Angle. Great. All right. So, first thing I want to do is figure out what I do with secant of theta if it's 2.5. Well, I know that the reciprocal ratio of secant is cosine. And to do that, I flip the fraction, right? So I write 2.5 as a fraction. And to find the cosine, I now have the reciprocal of the fraction. So I know we shouldn't have a decimal, but this is just for this is not my final answer. It's for the sake of using the cos inverse. And let's leave our answer to the nearest degree again. Okay, I got 66. Anyone else? Okay. Okay, so 66 degrees is going to be our RAA, and it will be our first angle because every angle is positive in the first quadrant. Now, because secant is a positive 2.5, which quadrants will this angle exist in? Well, it's going to be positive wherever cosine is positive. So that means we've got an angle in 1, and we've got an angle in 4, and they are all 66 degrees away from the x-axis. Cosine is positive in C and A. Oh, for now, I'm drawing my picture. And Lincoln's like, well, how about this? 540, what do I do with it? We shall see, right? Good thinking. But for now, let's just draw the picture. So this angle here is going to be 294, agreed? Okay. Okay. So I've got my diagram. Now, the third step is look at the restrictions. So do both of these angles, 66 and 294, satisfy the restrictions? Yes, because theta has to be between negative 360 and positive 540. So I've got two angles, 66 degrees and 294 degrees. Okay, let's start off with the negative part. How do I find the more negative angles? Well, I'm going to take each of these angles and I'm going to subtract 360. Okay, so 66 subtract 360 gives me negative 294 degrees. That works. What happens when I subtract 360 from 294? Ooh, fun. It's negative 66. Sometimes it works out like this. Sometimes it doesn't. Okay. If I subtract 360 again, I'm going to be outside my limit. But what I can do is I can now see what happens when I add 360. I get 426. That works. And what happens when I add 360 to the other first one? 294 plus 360. Ooh, that's 654 degrees. Does that one get included? No, because I can only go up to 540. So this one is not included. So how many angles are there? There are 5 angles that satisfy secant being 2.5. This is probably the hardest kind of question you're going to get. It includes everything we've done in this unit.
Is that like a thinkery?
No, it's not a thinkery, but it encompasses all the concepts. I'm gonna post some thinkery questions and we'll look at them on Monday.
I was gonna ask